Okay, so let's start with the part 4 of Python. So in this we are going to learn about some advanced features. Python has managed to reach a level that is high above others, making it the fastest growing language. Today you will see that it is the most popular language, and more and more people are learning, or they have already learned and using it quite extensively. So not only this, it is also a promising future, because various libraries are getting added to this, and because of that it is becoming very useful, very popular. There are various modules which are available. A module in Python is a file consisting of Python code. So you can use your module option and write your program in module form. A module can define functions, classes and variables. A module can also include runnable code. So a module allows you to logically organize your Python code. Grouping related code into the module makes the code easier to understand and use. A module is a Python object with the arbitrarily named attributes that you can bind and reference. Simply, a module is a file consisting of Python code. A module can define functions, classes and variables. A module can also include runnable code. So that is how the modules can be created. And it is always recommended that when you write your program, create it in modules, so that as and when you want, first, number one advantage is that it is very easy to debug it. The number two is that you can use it anywhere. You just pick up that particular module and use somewhere else wherever you want to. That is a very big advantage. Then example for that is that a Python code for a module named a name normally resides in the name.py. Py is the secondary name of the Python program, and here is an example of a simple module support.py. Now this is the script. It's very small script. This says that def print function, then print hello par, and then return. Now import statement is again a very useful function which is available in Python. You can use any Python source file as a module by executing an import statement. So you can import any module. Now there are so many libraries which are available also with Python, which we'll discuss, and these libraries can also be imported and made part of your main program. So Python source file will be completed with the help of these modules, and the import has the following syntax. The syntax is like import module 1, 2, 3, 4. You can import as many modules as you want. You can also write separate import commands for that. So that is how the module commands can be used in Python. When the interpreter encounters an import statement, it imports the module if whatever name you have given, and if the module is present in the search path, it is okay. The interpreter searches for that before importing a module, and then if it is, for example, for some reason it is not there, then it searches the entire path. So for example, to import a module support.py, and you need to put the following command at the top of the script, like this, as it is mentioned here. Like after giving the comment scripts like user bin Python, then import module, then import support. So when you write import support, it will immediately try and look for that. Now you can call defined function that module as follows, and support.print function Zara will be available. Now when the above code is executed, you will see the output like this as it is shown here. So a module is loaded only once, regardless of the number of times it is imported. So you need not import again and again, but in case even if you have written it, it doesn't matter. This prevents the module execution from happening over and over again if multiple imports occur. Now note that modules refer to the file containing Python statements and definition. A file containing Python code, for example, like example.py is called a module, and its module name would be example. We use modules to break down the large programs into small, manageable and organized files. So that is a very big advantage with the Python, that you can write your programs, break the total program, and then write in modules, so that you can easily manage it. The from import statement is also available. You can write like Python's from statement lets you import a specific attribute from a module into the current namespace. You will see when you will start writing programs in Python, you'll see that you can also import one particular attribute of a particular module. Now that is something which is very very useful. The from import has the following syntax, like from mod name import name 1, name 2, name 3, or whatever name up to a name n. So for example, to import the function Fibonacci from the module fib, use the following statement, like from fib import Fibonacci. This statement does not import the entire module fib into the current namespace. It just introduces the item Fibonacci from the module fib into the global symbol table of the importing module. So that is the advantage, that is the additional advantage of a Python, that you can import a particular attribute of that particular module. The from import statement, it is also possible to import all names from the module. That is also possible. So into the current namespace by using the following import statement, like from mod name import. This provides an easy way to import all the items from the module into the current namespace. However, this statement should be used sparingly. So you should always be clear about it, that what exactly you need. There is no point in importing everything, but if you need that, fine, you can always go for it. Locating modules. When you import a module, the Python interpreter searches for the module in the following sequences, like the current directory. If the module isn't found, then Python then searches each directory in the shell variable, like Python path. It also fails. If that also doesn't work, then Python checks the default path. On Unix, this default path is normally user local lib Python, or maybe in Windows, again that path will be searched by this. So the module search path is stored in the system module sys as the sys.path variable. This sys.path variable contains the current directory, Python path, and the installation dependent default. Now this Python path variable is an environment variable consisting of a list of directories. The syntax of Python path is the same as that of the shell variable path. Now here is a typical Python path from the Windows system, like set Python path is equal to like this, as it is mentioned, c python/lib, and here is a typical Python path from a Unix system also is given, like set Python path is equal to user local lib Python. So whatever system that you are using, whatever operating system that you have, accordingly you can write the command. Namespace and scoping. Now variables are names, identifiers that map to objects. A namespace is a directory of variable names and their corresponding objects. A Python statement can access variables in a local namespace and in the global namespace. So wherever you want, whatever way you want, you can use it. If a local and a global variable have the same name, then local variable shadows the global variable, because the local gets the precedence over the global one. But normally it is recommended that you should use different names. Do not use the same name in local and global. Now each function has its own local namespace. Class methods follow the name scoping rule as ordinary functions. Now, Python makes educated guesses on whether variables are local or global. Now Python itself has the capability to find out or to check whether the variable is only for the local module or for the global one. It assumes that any variable assigned a value in its function is local. So and as a programmer, you must also keep this in mind, that when you are defining a variable, you must be clear that whether you are defining it for the local module only or for the global purpose. Therefore, in order to assign a value to a global variable within a function, you must first use the global statement. This statement global var name, it tells Python that variable name is a global variable. So it is very easy, and it is easy for you to understand also. So Python stops searching the local namespace for the variable. That's how you can write your program. For example, we define a variable money in the global namespace, and within function money we assign money a value. Therefore Python assumes money as a local variable. However, we accessed the value of the local variable money before setting it. So an unbound local error is the result. Uncommenting the global statement fixes the problem, and in case there is a problem or error, something of that sort, then it will automatically take care of that. So this is the way you can define your global variables. Like the example is money is equal to 2000, def add money, then again the comment that is mentioned, and then money is equal to money plus 1. So money is taken as a variable, and then you can add 1 to that. When you print money, add money, print, you can see that the output will be there according to that. Now here module name is the name of the module you want to reload and not the string containing the module name. Example, to reload hello module, do the following, like reload hello. You can load and reload your module as and when you want it. Now packages. In Python, the package is a hierarchical file directory structure that defines a single Python application environment that consists of modules and sub-packages and sub-packages. So as many packages you want or sub-packages you want, you can do that. Consider a file pots.py that is available in the phone directory. So the file has following line of source code like it is mentioned here. Def pots, then print I am pots phone. Now these are some of the examples which you can easily understand, and maybe when you start writing the program you can easily take clues from this. Similar way, we have another two files having different functions with the same name as above, like phone/isdn.py. This is the name of the file, and this file having function isdn. Similarly, you can have phone g3.py file having function g3. Now create one file underscore init and then again underscore .py in the phone directory. So you can create a file also like that, phone/underscore init or _.py, and to make all these things you can see that this is the way it can be presented. So from pots import pots, from ISDN import ISDN, from G3 import G3. This is the way we can import your modules or any particular attribute from the other main modules. After you add these lines to this init.py, you have all of these classes available when you import the phone package. That is the advantage. Now import your phone package. You write import phone, and you will see that phone.pots, phone.isdn, phone.g3, all of them are going to be available to you. So then when the above code is executed, it produces the following result, like I am pots phone, I am 3G phone, I am ISDN phone. In the above example, we have taken example of a single function in each file, but you can keep multiple functions also in your files. So you can also define different Python classes in those files, and then you can create your packages out of those classes. So this is how the modules work. And modules, as I said, it is very, very useful and very powerful, and it gives you a lot of flexibility in writing your programs. So this completes your fourth part of the Python, and now we will move on to the fifth part. Thank you.